Thank you for inviting me to participate in this. So I'm going to talk about a review that our group did on worldwide CO2 guidelines for indoor air quality. And for some background, I work in a group at a public health department that's interested in health effects related to indoor air quality. And we are interested in developing indoor air guidelines for the state of California. And we thought we'd start with the issue of ventilation and CO2 measured as a proxy for ventilation. And we thought we would start that by looking at what have other people already done in terms of setting indoor guidelines or standards for CO2. And what were they trying to accomplish by setting these guidelines, and what evidence did they have that setting their guidelines accomplished their goals? So you all probably understand this very well already, that ventilation dilutes indoor generated air pollutants and it reduces indoor exposures, including to viral bioaerosols from other occupants. And historically, minimum ventilation rate limits were health-based back when they were worried about tuberculosis, but recently we would say that they're more odor-based, which people often describe as comfort-based. And since the COVID era, there's been renewed recognition worldwide that ventilation is important for health, although people did not used to pay very much attention to that in recent years. But ventilation is difficult to measure in many buildings. And for that reason, many ventilation rate guidelines specify indoor CO2 concentrations as proxy limits for ventilation rates. But it really has not seemed clear what was the basis used for setting the various CO2 limits that you might hear about. And so we reviewed worldwide CO2 guidelines and what evidence the guidelines each provided for the limits that they'd set. And our goal was to see, was there scientific support available in guidelines that had been set, documenting that these guidelines were protective against health effects, such as airborne infectious disease transmission, which is something people are thinking about much more these days. So we started our review with the ISIAC STC 34 database, which did a lovely collection of international IAQ guidelines. We supplemented that with a current literature review. We then excluded occupational limits. There's occupational limits from various organizations of, say, 5,000, 10,000, 20,000 parts per million of CO2 for very well documented health effects at those high levels, not usually found in indoor environments normally. And we found 43 CO2 guidelines from various nations or international organizations, and every guideline was a maximum value of different kinds. Some were one-time maximum values, some were time average values, some set single limits, and some set multiple limits at different tiers that you might think of as good, better, or best. Some set absolute indoor limits, and some set limits as a differential above outdoors. And this box just shows you some sample guidelines from various countries. Here is a plot of the guidelines that we found. And I will explain that if there were multi-tier guidelines, only the lowest tier is in this plot. If there were differential limits set, we essentially estimated that outdoors would be 400 and put the corresponding indoor limit in here. And the color in the plot, as explained in the key, shows the effect that the guideline was supposed to protect the occupants against, which might have been they didn't specify at all. They were protecting occupants against odor dissatisfaction, or sometimes it was non-infectious health effects, which might have been non-specific symptoms, or could they have been protecting the occupants against infectious disease transmission. And so this plot shows basically all of the limits that we found in the 43 guidelines. One guideline which included 17 values in the one guideline was omitted here for clarity. You can see the most common value was 1,000, ppm indoor CO2, and we can talk about why that is so common. We didn't really find a scientific basis for it, but that was the most common number. This is a plot of the 8 guidelines which set multiple limits, multi-tiered limits, and they vary quite a bit. So there's not really clear agreement on what would be good limits for indoor air quality. So what was the evidence basis for these guidelines as explained in the guideline documents? So few provided any evidence at all for the limits that they set, and most of them that did provide any evidence were setting them to protect occupants against odor dissatisfaction. And we think that 1,000 ppm was so popular because there was some earlier research suggesting that indoor CO2 at 700 ppm above the ambient was sufficient to control the occupant odors in terms of the ventilation that corresponded to. And very few guidelines provided any evidence that their limit would protect the occupants from any health effect at all. And most of the guidelines, as far as we could tell, displayed no understanding of the scientific basis for setting a CO2-based ventilation rate limit. And some, in fact, even set average CO2 limits, like an 8-hour time-weighted average of CO2 at a certain level, suggesting some confusion about the scientific basis for setting a CO2 limit, which, as far as we know, it can only be based on a mass balance model and a steady state CO2. And here, the numbers on the right here just show that very few guidelines in our opinion, provided substantial information, substantial evidence that the limit they set would actually protect the occupants against the effect that the guideline was concerned with. And then ASHRAE since then has set some various limits related to ventilation. 241 did not set CO2 limits, and 62.1 addendum AB set CO2 limits corresponding to 62.1 airflow standards, but those are arguably odor-based. This is just a table showing the 43 guidelines that we found separated out by what was the effect that the guideline said it was intended to control, and how much evidence did the guideline provide that the guideline was effective at that limit. And there were, again, very few guidelines that seemed to have substantial evidence to support their limits being effective. Most of those were related to odor. Only one was related to health effects of indoor airborne transmission of disease. And this was the guideline from the Nordic Ventilation Group, which was later adopted by REVA, and it was called their Proposal for Post-COVID Target Ventilation Rates. And this guideline had clear goals, a clear approach, and clear assumptions, and they set 17 example limits for defined spaces and occupancies. And their process was, first, they set minimum ventilation rates based on a model of airborne infection that would control risks of indoor long-range transmission of airborne COVID. And based on that minimum ventilation rate limit, they set corresponding CO2 limits based on a mass balance model for steady state CO2 estimated at the minimum ventilation rate limit they had previously calculated. And this was the most carefully constructed CO2 guideline that we found. And even the best CO2-based limits for IAQ do have lots of limitations. For instance, they have technical limitations because an indoor space frequently will fail to reach a steady state CO2 and may never reach steady state CO2. There's a lot of invalid assumptions in applying a CO2 limit to most indoor spaces. And there's also measurement errors in measuring CO2. And there's also practical limitations in setting and enforcing CO2 limits for indoor air quality, because different spaces different space uses will have different expected steady state CO2 levels at the ventilation rates recommended for those spaces. And so bottom line, there's no single limit like 1,000 ppm that would be a correct limit for all spaces, even though people would like it to be that simple. So in conclusion, of the 43 identified CO2 guidelines we found, 16 did not specify any adverse effect they were intended to control. 19 specified odor, 8 specified health, but only 3 of the 8 specified control of infectious disease. 25 of these 43 provided no supportive evidence for their guidelines that they set, and we found only 8 provided persuasive evidence, and only one of the guidelines that we found developed limits from scientific models to control airborne COVID-19 transmission, and most seem to show no apparent understanding of a scientific basis of setting a CO2 limit for indoor air quality in the first place. And so 3 common practices we found with no scientific basis that we could identify. One is setting one CO2 limit for indoor air quality across all buildings. Another is setting a CO2 limit for indoor air quality as an extended time-weighted average, like 8 hours or longer. And another was saying that you should make any arbitrary one-time CO2 measurement and use that to verify that you have a desired ventilation rate. And that is the end of my conclusion. End of my paper. If you would be interested in reading this paper, there's online-only access for the published article at the site for the Journal of Exposure Science and Environmental Epidemiology in 2024. Or if you contact me, I will be happy to send you a PDF. Any questions?